All right, algebra, we are in lesson 4. Now we're going to compare. I always forget to turn on my pen. Compare quadratic and exponential functions. Remember, quadratic looks like, we're going to do standard form. This is called ax squared plus bx plus c. And exponential is y equals a to the x. Or b to the x, we always said, didn't we? Sorry. Okay, that's the difference, quadratic and exponential. All right, list these quantities in order from least to greatest without evaluating each expression. Be prepared to explain your reasoning. All right, let's look to see what's going on here. I see 2 to the 10th and 2 to the 9th. Those have the same base with different powers. If I raise 2 to the 9th power, it's going to be smaller than 2 to the 10th power. Okay, so that is going to be in those orders. Now, if I look at b, 10 to the 2nd power and 9 to the 2nd power, they're raised to the same power, but they're different bases. So 9 to the 2nd power is going to be smaller than 10 to the 2nd power. Now we need to order these 4. Anything raised to a higher power should be bigger than something raised to the 2nd power. This is just 81, and that's 100. I know it said don't evaluate them, but those should be much smaller than something raised to a 9th power, because that's exponential growth. This is exponential. It's always bigger. And this is just quadratic. So our order would be D, B, C, A. D, B, C, A. Cool. In pattern A, the length and width of the rectangle grow by one small square from each step to the next. In pattern B, the number of small squares doubles from each step to the next. In each pattern, the number of small squares is a function of the step number, n. So let's see if we can write some equations. Write an equation to represent the number of small squares at step n in pattern A. So I'm working in pattern A. Looks like here, one step I have 1 square. Step 2 I have 2 by 2, which is 2 squared. Step 3, 3 by 3, which is 3 squared. So here I believe my equation is going to be y equals n squared. And if I look at pattern B, step 0 is 1. That's my initial value. Step 1 is 2. So I've got 1, I have 2. Step 2 is 4. Step 3 is 1, 2, 3, 4, 5, 6, 7, 8. If I divide, 2 over 1 is 2. 4 over 2 is 2. 8 over 4 is 2. It has a common factor. So we know that's exponential. I do my factor raised to the n power. That's how we learned how to do that in the exponential unit. So our function for A is quadratic and B is exponential. Now we're going to complete that table. I don't even need to see the figures to complete the table. I know that my y equals 2 to the x and y equals, not 2 to the x, I'm sorry, n squared. Let's see if that will still erase. Good, it does. Sometimes if I change pen colors, it doesn't. So here, let's fill in 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 6, 7, and 8. 0, 1, 4, 16, 25, 36, 49, and 64. Here we're doing, nope, wrong color. 2 to the 0. 1 to the 0. Goodness, I'm sorry. Start over. 2 to the 0. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, etc. You can tell my brain has a hard time switching between exponential and quadratic. I just did it again. 2 to the 8th power. Anything raised to the 0 power is 1. 2 to the 3rd power is 8. 8 times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. Let me check that last one. Yep, 256. So we've got our tables. We're good. How would the two patterns compare if they continue to grow? I think we can say that they're naming it figure, pattern B is going to grow much faster. Okay, much faster. Pattern B will grow. Any other sample observations? When n equals 4, they're the same, right? That's an observation. So anything above pattern 4, anything above step 4, pattern B is always going to be bigger, always, always. So when n is greater than 4, pattern B is greater than pattern A. When n is equal to 4, they're equal. We can even say when n is less than 4, pattern A is greater than pattern B. So here are two functions, p of x and q of x. You remember that's how we say them. Investigate the output, which would be the y values of p and q for different values of x. For large enough values of x, one function will have a greater value than the other. Which function will have the greater value as x increases? Support your answer with tables, graphs, and other representations. I made the graphs on Desmos to help us. This right here is q of x equals 3 to the x. This right here is p of x equals 6x squared. So q of x grows much faster. We are exponential here. Now the graph that I put in here doesn't show everything we need. So let's do, sorry, my kids are eating lunch. That's going to be a little loud. Let's do a quick table. So x, p of x, and q of x. So x is my input. I'm going to do an input of 0, 1, 2, 3, 4, 5, 6, 7. P of x is going to be my output. So when I input 0, my output is going to be 0. I'm just plugging in 0 for this x right there. When I plug in 0 for q, I get 1. I plug in 1 for p, I have 6 times 1 squared, which is 6. I plug in 1 for q, I have 3 to the first power, which is 3. Okay, plug in 2. 2 squared is 4 times 6 is 24. Let's plug in 3 for p of x. Let's stick with p of x. 3 squared is 9 times 6 is 54. 4 squared is 16 times 6 is 96. 5 squared is 25 times 6 is 150. 6 squared is 36, times 6 is 216. 49 times 6, so 7 squared is 49, times 6 is 294. Okay, so it grows pretty well, but let's see how the exponential one grows. So if I plug in 2 for q of x, it's 3 squared. I plug in 3 to the third power. P of x is still bigger. Plug in 4, 3 to the fourth power. P of x is still bigger. 5, 3 to the fifth power. Finally, q of x took over. 3 to the sixth power and 3 to the seventh power. So we see that q of x is going to take over a lot faster. Once your input is 5, q is bigger than p. I don't know what else to tell you here. I think we hit it all. We see the difference between quadratic. This is called a parabola. An exponential. Okay? We see the difference. Cool. Good job.